Hey everyone, and welcome. Today, we're going to pull back the curtain on SQL, the incredible language that's quietly running in the background of almost every app and website you use. It's how we talk to databases, those massive digital brains that store and manage pretty much all the world's information.
So, here's our game plan for today. We'll kick things off with the absolute basics. What even is SQL? Then we're going to follow the life cycle of a database. First, we'll build the structure with something called DDL. Then we'll actually put data into it using DML. And finally, we'll lock it down and make it secure with DCL. By the end, you'll see exactly how it all clicks together.
All right, let's dive right in. First things first, what exactly is this thing called SQL?
I mean, just stop and think about it for a second. Every single post you scroll past, every item for sale in an online shop, every person on your friends list, that's all data. How on earth does a system keep track of billions of pieces of information and give it to you instantly? Well, the short answer is databases.
And SQL, which stands for Structured Query Language, is the universal language we use to communicate with those databases. It's how we give them instructions, ask them questions, and tell them precisely what to do with all that information.
Okay, so before you can even think about storing data, you need a place for it, right? A container. That's the whole job of our first category, DDL, which stands for Data Definition Language. You can think of this as the blueprint phase.
And honestly, the bookshelf analogy is perfect here. You wouldn't just dump all your books into a big pile on the floor, would you? Of course not. You'd build a proper structure with different shelves for fiction, for biographies, for cookbooks. DDL is how you design and build that organized digital structure for your data.
And these are your main tools for the job. Create is exactly what it sounds like. You use it to build the bookshelf itself, or in our world, a new table. Alter lets you change that structure later on. Maybe you need to add a new column for a student's email. Truncate is like yanking all the books off the shelf at once to start fresh, but the shelf itself stays. And drop, well, that's like taking a sledgehammer to the entire bookshelf. It's gone, structure and all.
And this is what it actually looks like in practice. This one line of code is just a formal way of saying, hey database, I need a new table called students. Make sure it has a spot for their ID number and another spot for their first name. And boom, just like that, your structure is created. That is DDL in a nutshell.
All right, our bookshelf is built, it's sturdy, it's organized, but it's totally empty. Now we got to actually put some books on the shelves, move them around, maybe take one out to read. This is where DML, the data manipulation language, comes into play.
These are your everyday action verbs in the world of SQL. You'll use insert to add a new student to your table. You'll update their info if it changes. You might have to delete their record if they leave the school. And most of all, you'll use select to actually look at the data.
See how straightforward that is? We're telling the database to insert a new record into our students table. We're giving it student ID number 1 with the name Jane and putting it right into the structure we just created. It's just like placing a brand new book on the shelf.
But what if we made a typo? Or maybe Jane now goes by John? No problem. The update command is here for that. Now, look closely at that where clause. This little part is so important. It tells the database to only change the name for the student where the ID is 1. If you forgot that part, you'd accidentally rename every single student in your entire table to John.
Okay, but select is the real rock star of DML. It's how you ask questions and get answers from your data. This command is basically saying, hey, go into the student's table and select everything. That's what the little star means. For the student where their ID is 1. And there's that where clause again, being our hero and making sure we get back exactly the information we asked for. Okay, our database is built and it's full of valuable data. This brings us to a really critical question. Who's allowed to see this stuff? And maybe even more importantly, who gets to change it? This is where DCL, the data control language, comes in. Yeah, the best way to think of DCL is as the security guard for your database. It's the bouncer at the door, checking IDs. It decides who gets in, who just gets to look around, and who gets the VIP pass to actually make changes. It is all about controlling permissions. And this is why DCL is so critical in any real company. A database administrator, for example, needs God mode. They need full permissions to build and manage everything so they can grant access to others. But a data analyst? They probably just need to read the data using select. They definitely shouldn't be able to change it. DCL makes sure everyone has exactly the power they need and no more.
All right, we've gone through the three main flavors of SQL. So let's take a step back now and look at the big picture to see how this all really works together.
This table right here, this is the perfect summary. It really boils everything down. DDL is your architect. It defines the structure. DML is your librarian. It works with the data inside that structure. And DCL is your security guard. It controls who gets access. Structure, manipulation, and control. If you can remember those three jobs, you've got the core of SQL down.
And this is pretty much how it plays out in the real world every day. First, you design and build a database using DDL. Then, developers write the code for their apps using DML to talk to it. Next, you lock it all down with DCL. And then, it's all about maintenance, keeping it running smoothly. It's a never-ending cycle.
So there you have it. We've gone all the way from a completely empty blueprint to a secure, organized, functioning database. You now understand the absolute fundamental building blocks of how data is managed all over the world. So the only question left is, now that you know the language, what questions would you want to ask? What would you want to build?